So there are two forces that we've dealt with so far in this course that we're going to go ahead and explicitly calculate out what the work done by those forces is. The first of those is the gravitational force. If I have an object that's sitting in the Earth's gravitational field, I know there's going to be a gravitational force that acts on that object. It's going to pull that object down, and the magnitude of that force is going to be equal to the mass of the object times the Earth's gravitational acceleration, 9.8 meters per second squared. So the first detail I want to pay attention to, of course, is that gravitational force is constant. And so one of the things we said is if I have a constant force, then the work done by a constant force can be given by the magnitude of the force times the magnitude of the displacement times the cosine of the angle between them. And so the first thing that we'll do is think about what sign should I get for the work done by gravity depending on how my object moves. So let's take my object, and for starters, let's just let that object move straight down. So for an object that moves down, I know that the gravitational force and the displacement point in the same direction. So the angle between them is 0. The cosine of 0 is positive 1, and so I get that the work done by gravity for an object moving down must be positively valued, because I'm going to take a positive magnitude for the gravitational force times a positive magnitude for the displacement times a positive 1 for my cosine term. On the other hand, if my object starts in a lower position and moves straight up, well, now in this case, the gravitational force and the displacement point in opposite directions. So the angle between these two vectors over here on the right is now 180 degrees. The cosine of 180 degrees is negative 1. And so again, when I multiply magnitude of the force times magnitude of the displacement times negative 1, I get that the work done by gravity for an object moving up has to be negative. So in terms of signs, before I do anything in terms of thinking about a calculation, let's just make sure that it's clear what signs I should get based on how my object is moving. The gravitational force does positive work on objects moving downward. The gravitational force does negative work on objects as they move up. So in terms of calculating this out, well, let's let my object just move sort of randomly here. So delta R now has two components. It's got a horizontal component, delta x, and a vertical component, delta y. And one of the things we talked about when we were talking about calculating the work in general is that sometimes it's useful to pair up delta R and the cosine phi term and simply think about that as the component of the displacement that lies along the same line as the gravitational force. And so in this case, because the gravitational force points vertically downward, what that means is this displacement cosine phi term basically says just care about the vertical component of the displacement. And so I can calculate out the work done by gravity as negative mg delta y. And so the first thing let's do is let's check and make sure that this is consistent. So notice a couple things about delta y. One, it is just the vertical displacement, not the total displacement. So again, the horizontal displacement, gravity does no work for an object that's moved horizontally. Gravity only cares about how the object is moved up and down. Second, notice I'm burying a sign inside delta y. So if my object moves up, delta y is positively valued. If my object moves down, delta y is negatively valued. And so if I think about how delta y is defined, if my object moves up, delta y is positive. Multiply that times positive 9.8 meters per second squared for the gravitational acceleration times the positive value of the mass times a negative sign means that I get that the work done by gravity as an object moves up is negative. Negative times positive times positive times positive is going to give me something negative. That's consistent with what I know the answer is supposed to be, that the work done by gravity is negative for an object that moves upward. On the other hand, if my object moves down, I know that delta y needs to be negative. Multiply that negative delta y times positive g times positive mass times the negative out front. The negative out front is going to cancel the negative in my delta y, and sure enough I end up with work done by gravity being positive for an object as it moves down. This equation gives me the right value for the work done by gravity, and it's consistent with what I know the signs need to be as long as I'm accurate about making sure I get the right sign plugged in for delta y. How about instead of worrying about the sign of delta y, we just worry about the sign of the thing we care about in the first place, which is the work done by gravity. So I'm going to rewrite the work done by gravity, and so the way I'll usually calculate it out in class is this way. The work done by gravity is equal to plus or minus positive mass times positive gravitational acceleration times a positively valued vertical distance. So m, g, and delta h are all going to be positive, and I'm going to be responsible for making sure the right sign gets out in front. If I have an object that moves down, I know that the work done by gravity will be positive, and so I'm just going to leave the positive sign out front in this equation. On the other hand, if my object moves up, I know the work done by gravity on an object moving up is negative, and so I'm just going to choose the negative sign. And so it doesn't matter if I have an object sitting down here in the lower left-hand corner and it moves up and to the right. Well, I know I don't care about the to the right in terms of the work done by gravity, but I do care about the up, and in moving up, I know I'm going to need a minus sign. And then I'm going to multiply mass of the object times positive 9.8 meters per second squared times whatever that vertical distance is as a positive number. On the other hand, if my object starts up here and moves down and to the left, again, the work done by gravity doesn't care about the to the left part, but in moving down, I know I need the positive sign. And then I'm going to multiply positive mass times positive 9.8 meters per second squared times, again, a positive distance. So delta H is always going to be positive, and I'm simply going to take care of the sign for the work done by gravity out front.